Conditional probability and independence with group A2. Brandon Gardner, Daniel Moore, Matt Goldstein, and Stephen Woodruff. To learn more topics on discrete math, please visit www.noatom.com. Conditional probability is the probability that an event occurs, given the fact that a related event has already occurred with a certain outcome. For instance, what is the probability you roll 3 2s in 4 rolls of a die, given that the first roll is a 4? Let E and F be events with the probability of F being greater than 0. The conditional probability of F, given E, is denoted by the following. It is defined as the probability of the intersection of E and F over the probability of F. In general, F is considered to be the sample space. An example of conditional probability follows. What is the conditional probability that a random generated bit string of length 4 contains at least 2 consecutive zeros, given that the first bit is a 1? Assume that the probabilities of a 1 and a 0 are equally likely. First, we need to enumerate the possibilities that fit. Each one must start out with a 1 and must contain 2 consecutive zeros. These are the events that fit. Now we have to enumerate the total number of events. Since the first digit is already given to us as a 1, but the next 3 digits can be one of 2 choices. Because of this, we have 2 times 2 times 2, which equals 8. This means that there are a total of 8 possibilities. So now, according to our formula, we take the number of events that fit our description, which in this case is 3, divided by the number of total events, which in this case is 8. Therefore, the probability of a bit string length 4 starting with a 1 contains 2 consecutive zeros is 3/8. Independence is our next topic. Independence is where events produce the same result even when the event occurs by itself. The events E and F are independent if and only if the probability of the intersection of E and F equals the probability of E times the probability of F. Here is an example. Are the events E that a family with 3 children has children of both sexes, and F that this family has at most 1 boy independent? Assume that the 8 ways a family can have these 3 children are equally likely. First, we must enumerate the total number of possibilities. and so on. There are a total of 8 of these. Now, we must enumerate the possible options that fit E, which is that a family contains 3 children and has both sexes. These are as we can see, there are 5 possibilities. Next, we must enumerate the ones that fit F, or that there is at most 1 boy. Now we must look at their union. Together, these form since the probability that a family contains children of both sexes is 6/8, and the probability that it contains at most 1 boy is 4/8, and their union is 3/8, we can see that their union, once again, which is 3/8, equals each of the individual probabilities multiplied together. They have been reduced. Oops, this is so 3/4. 1/2 equals 3/8. Because they are equal, they are in fact independent. This, however, does not hold if you change the number of children. There are 2 types of independence: pairwise independence and mutually independent. A list of random variables exhibits pairwise independence if any 2 variables are independent. Mutual independence occurs when the events E1, E2, all the way through En, if their probability is equals their individual probabilities multiplied together.